Hi class, this is Miss Best. This video is on piecewise functions. Alright, so your goals for this lesson is to be able to represent piecewise functions and use piecewise functions to model real life quantities. Alright, so the first thing we're going to do is go over some vocabulary. What is a piecewise function? A piecewise function is a function represented by a combination of equations, each corresponding to a part of the domain. Alright, and a step function is another kind of piecewise function. A step function is a piecewise function whose graph resembles a set of stair steps. And you'll be able to see what it looks like. It actually looks like stairs going up on the graph. Alright, so our first example is learning how to evaluate a piecewise function. So it says evaluate f of x when a, x is equal to -3, and b, when x is equal to -1. So here's our function f of x right here. And it's broken up into two pieces. The two pieces are x minus 4 and 3x minus 1. Now each piece, alright, two pieces here. Alright, each piece has its own domain. So for the first piece, x minus 4, the domain is x less than -1. So only values of x that are less than -1 can go into this function. And then the second piece, 3x minus 1, has a domain of x greater than or equal to -1. So only x's that are greater than or equal to -1 can go into this function. Alright, so part A, it says f of x equals x minus 4. Now part A, we have to evaluate for x equals -3. Because -3 is less than -1, we have to use the first equation. And that's x minus 4. So we're going to plug in -3 for x into the first equation. Okay, and so that becomes -3 minus 4. And then -3 minus 4 is -7. Alright, so the next one, part B, we have to evaluate for x equals -1. So because -1 is equal to -1, we have to use the second equation. Okay? Because -1 would be in this domain because it's greater than or equal to. Alright, so we're going to evaluate for -1. So f of -1 equals 3 times -1 minus 1. 3 times -1 is -3, and then minus 1, that would be -4. Alright, let's go on to the next example, which would be graphing a piecewise function. So graphing a piecewise function is it's just like graphing a regular function, except you're going to eliminate the parts of the graph that are not in the domain. Alright, so here's our function f of x. We have two pieces again, -x plus 1 if x is less than 0, and 2x plus 1 if x is greater than or equal to 0. Alright, so the first thing you're going to do is graph the pieces as if they were just normal linear functions. So for this first one right here, we're going to start with -x plus 1. We're going to start with 1. Okay, make a dot here. And then our slope is -1. So we're going to go up 1 and to the left. Up 1 and to the left. And keep doing that. Alright, and it says if x is less than 0. So the only piece of this function that can be on the graph is the piece that's less than 0. So from here to the left is where x is less than 0. Also, just like when we graph on a number line, if it's less than, that means you're going to have, if it's less than or greater than, that means you're going to have an open circle. And if it's less than or equal to or greater than or equal to, you're going to have a closed circle. Okay? Alright, so I'm going to draw an open circle right here. And then draw my line to the left. Alright, so that's f of x down. That's -x plus 1 down. Alright, now we have to do 2x plus 1. So again, you start off graphing it just like a normal line. So I'm going to start at 1. And then my slope is 2, so I'm going to go up 2 over 1. Up 2 over 1. and I can go the reverse direction. All right, so it says if x is greater than or equal to 0. So I only graph the part where x is greater than or equal to 0. So here's 0, and all values to the right would be greater than 0. So I'm only going to graph the part to the right. And since it's greater than or equal to, I'm going to fill in the circle here. Okay. And so that would be all I would do for that graph. Now, the part of the solution here, let's fill in the blanks. It says to the left of x equals 0, the graph is given by negative x plus 1. To the left of 0, this graph is negative x plus 1. Okay. And to the right, and including x equals 0, the graph is given by 2x plus 1. This part right here. This is 2x plus 1. So the graph is composed of two rays with the common initial point. This would be their initial point because this is where they meet up together, of 0, 1. All right. So that's it for this video, and come back for part 2, and I'll see you guys tomorrow.